Good morning, students. This is Aisha, and let us continue with our first chapter of chemistry, that is matter in our surroundings. In my last video, I dealt about matter, what is it composed of, what is the definition of matter, and also the characteristics of matter. Today, we'll be learning about a very important concept, that is effect of change of temperature on the state of matter. So let's see how a change in temperature affects the state of matter. You can see over here an experiment setup having a beaker containing ice, and it is placed on a tripod stand with a wire gauge, and it is heated with the help of a Bunsen burner. Now slowly you can also see a thermometer to record the temperature. So slowly, as the temperature increases, we have learned in our previous video that as the temperature increases, the kinetic energy of the particles also increase. So during this, the intermolecular forces of attraction, also we have learned as one of the characteristics of matter, that the molecules, the particles tend to attract each other. They have a force of attraction between them. They are held with a force of attraction between them. So slowly as the temperature increases, what happens is the intermolecular or interparticular force of attraction between the particles, it reduces, and the particles get detached and begin to vibrate and also begin to move away from each other freely. That we can see as the temperature rises from -degrees centigrade to 0 degrees centigrade. Now here what happens is you provide heat energy to the ice particles, and slowly you can see that the temperature increases from below 0 degrees and it goes towards the 0 degrees. But at one stage, please listen carefully children, but at one stage you can see no net increase in the level of the mercury. You can see no increase in the level of the mercury in spite of the fact that you are continuing to supply the heat energy. The thermometer doesn't show any increase in the temperature. The mercury level stands still until all the ice melts away. So the melting procedure, it starts and it continues, and during this the mercury will not show any increase in its level. So once all the ice in the beaker changes to liquid, then the mercury starts rising again. This level of the thermometer or the mercury, where it is standing still for some time, is nothing but called the melting point of a substance, because we have started with a solid substance here. So when you are providing heat energy, it starts to melt. So this level of the mercury, where the thermometer is not showing any increase, it is standing still for some time, that level is called as the melting point of a substance. Now what is the melting point of a substance? It is the temperature at which the solid melts and converts into liquid at atmospheric pressure. So melting point is nothing but a temperature. You need to understand a very important point here children. So you can, as I've already told you, in spite of continuously heating the substance, why the thermometer is not showing any increase? So it doesn't mean that we are not supplying any heat energy. We are continuing to supply the heat energy. In spite of that, the mercury level is not showing any increase in the temperature. So where is this heat energy going into? So this heat energy, where is this going? Why is it not shown up in the thermometer? So this heat energy, which is not shown up by the thermometer or which is hidden in the substance, is called as latent heat of vaporization. I'm sorry, here it's called as latent heat of fusion. Latent heat, so which literally means hidden heat. It means hidden heat. And this is happening at the melting point of a substance in our experiment. So it is called as latent heat of fusion. Latent heat of fusion. So in fact, this hidden heat is actually utilized by the particles of the substance. The hidden heat is utilized by the molecules of a substance to overcome, well, how is it used now? It is using this energy to overcome the intermolecular forces of attraction. Because in order to convert from solid to liquid, first of all, the molecules have to be loosened. So when will that happen? When they overcome the forces of attraction to get rid of the forces of attraction, such that the molecules will be free to move from each other, resulting in the change of state of matter. Hope this is clear, children. What is latent heat of fusion? It is the amount of heat energy which is actually hidden, that is utilized by the substance to get rid of the intermolecular forces of attraction to become a liquid. You know how molecules are arranged in a liquid. They are not so tightly packed, isn't it? So to become loose, they have to get rid of the intermolecular forces of attraction, and that is done by utilizing the heat energy at its melting point. So this is nothing but called as latent heat of fusion. It is the amount of heat energy that is required to change 1 kilogram of solid into liquid at atmospheric pressure. And where is this all happening? At the melting point of a substance. Now, you continue to heat it. Once this all becomes water, it changes into liquid, you continue to heat it. So what happens? Again the mercury level soars or increases, and again it reaches to some temperature. Now what happens? Now the water slowly starts to boil and it starts to change into vapor. So that time also you can see that the mercury level, after reaching a particular level, it stops. You won't see any increase in the mercury level in spite of the fact that you are continuing to heat it. Now it will continue, it will stand still until all the water, all the liquid water gets converted to vapor. So what can you understand here? The hidden heat is utilized by the molecules of the liquid. The hidden heat is utilized by the molecules or particles of the liquid to overcome the forces of attraction and become more free. They move very far from each other such that they change into gas. So at this point of time, we call it as the hidden heat as the latent heat. It is also hidden heat because it is not shown up in the thermometer. So it is called as latent heat of vaporization. What is it called, children? It is called as latent heat of vaporization, and it is nothing, it is defined as the amount of heat energy required, the amount of heat energy that is required to change 1 kg of liquid now, because it is happening at the boiling point of a substance. 1 kg of liquid into vapor state or gaseous state, into gas, I can say. Yes? So this is about the latent heat of vaporization. One more very important thing you have to listen, children. For any solid substance, in order to change to liquid, it has to get the energy equal to latent heat of fusion. Otherwise, it will not get transformed, or it won't change into liquid. So in order for the solids to convert into liquids, the solids should obtain or get the amount of heat energy equal to the latent heat of fusion to change into liquid. In case it doesn't get that amount of heat, it will not get converted to liquid. In the similar manner, for liquids to change into gas or vapor, the liquids should get the amount of heat equal to latent heat of vaporization to change into gas. Did you understand, children? It is only then that the solids will change to liquids, or the liquids will change to gas. Hope it is clear, children. That's all for today. And tomorrow we shall see the effect of pressure, the effect of change of pressure on the states of matter. Thank you, children.